Hi everyone, we are Group Broski, and today we're excited to present our mini project titled Guess the Movie, an interactive movie recommendation system. My name is Swanta Lin, and I was responsible for back-end coding and creating the presentation slide that summarize the entire project.
Hello everyone, I am Susan Ling. My main responsibility was to design the system architecture and flowcharts, making sure our structure was logical and well organized.
Hi everyone, I'm Group Mojo. I focus on the front-end coding, working on the user interface and interactive component using IPyWidgets, HTML and CSS.
Together, we collaborated closely to design and build a working interactive Python-based system that helps users discover movies in a fun and efficient way. The idea for our project came from a common problem: deciding what movie to watch next. Today, with so many films available, people waste a lot of time scrolling through endless lists. One platform like Netflix use advanced machine learning models to recommend movies. Those methods are complex and out of scope for a small project. So we focused on simplicity, algorithms, and interactivity. Our system uses section, sorting, and stacks, not AI, to deliver fast, dynamic results. This project demonstrates how basic data structures and algorithms can be used to create a functional, fun, and interactive application. Now I'm gonna talk about the main concept and the project overview. Our system allows users to search movie by title or genre, and it's sorted by rating, year, or title in an ascending or descending order. It also manages a recently watched list using a stack data structure. It also interacts through a clean and a responsive UI built with IPyWidgets. We used Python as a main language, combined with linear search, quick sort, and stack for logic. The design blends backend algorithm with a front-end interface to give a smooth user experience.
Let's look at the system architecture. The flow begins when a user types something into the search box or click a control button. The system determines which function to trigger: search, sort, show all, watch, or clear history. For search button, it triggers a linear search through the dataset. And for sorting, it triggers a quick sort based on the selected key. And for watch button, it pushes the movie into the recently watched stack. And for recently watched function, it retrieves stack items in less in first up order. And finally, for the clear, it resets the stack in counters. All these actions update the display area dynamically, and thanks to the event handler functions for connecting each widget. And here's the flow chart to visualize this. When the program starts, it loads the dataset. Right now we have 40 data in our dataset manually, and user will put some kind of input via search box and click buttons, and based on that we will do some kind of sorting or watch movie based on the user. If user didn't put anything in the search box, it will show all the data, all the 40 movie datasets. After user updating, clicking the search button or sort button or watch movie, it will update the UI widgets and display the result based on the user input. And finally, user can see the recently watched stack based on how he clicked the movie. And that's the end of the program. And for a quick summary, I use linear search for search button, and also quick sort. There will be 3 parameters: movie key and reverse is true or false. And also watch movie, and there will be show recently watched function, and we will check is movie already watched or not for recently watched function. And there will also be a clear recently watched for clearing the counters and recently watched button. And there will be update stats which will be called after clicking on such click or on show or click or on watch click. And finally, we will display the movie with widgets based on the movie. Actually, there will be two functions for displaying movie. One is for each movie and another one is for the entire movie list. Let's look at the system architecture. The flow begins when a user types something into the search box or clicks a control button. The system determines which function to trigger: search, sort, show all, watch, or clear history. For search button, it triggers a linear search through the dataset. And for sorting, it triggers a quick sort based on the selected key. And for watch function, it pushes the movie into the recently watched stack. And for recently watched function, it retrieves stack items in less than fast order. And finally, for the clear function, it resets all the stuck encounters.
Let me explain the scope step by step. Basically, this is a movie recommendation system that let at such movie by title or genre, that sort movie by rating, year or name, which is basically with the markdown. And this is for show, and there is also a button that is for recently watched button, and this is for beautiful interactive user interface using Jupyter widgets. So the first thing, we imported the tools that we need, which is the IPython.display, which we can display the HTML for styling, markdown, or clear output. And the next thing is IPyWidgets that allow us to create user interactive design, but like buttons, text boxes, drop down, that kind of thing. And for this tool, this is for the time for our movie and adding small delays. This is a list of dictionary for our movie dataset. Basically, this is a manual one that we do with 40 movies. In each dictionary stores the details about one movie, which is the title, that we have to put the movie name, rating, for IMDb rating, for year, this is for the release years, and genre with a list. This is for searching movie. Right now, we are using the linear search, checking one movie at a time. It looks for the keyword inside the movie title or genre, and return all movies that match the keyword. For example, if we search the keywords like drama, then it will return all movies with drama in their genre list. And this function uses the quick sort algorithm to sort the movie list, as we can see here in the movie name. We can sort by rating, year, and title, whether it's in ascending or descending order, which is high to low or low to high, newest to oldest, that kind of thing. We can choose this with a drop-down button. This is for the recently watched movie stack. This program keeps track of what we have watched using a stack. And this watch movie function adds a movie to the recently watched list. And for show recently watched function, it shows the most recently watched facts. For its movie watch function, it checks if we already watched or not. For the clear recently watched function, it removes all the watched movie. And this is for the custom part for custom CSS part for styling. This adds a beautiful styling to make our interface look more modern and clean, like a real website, although we're running it in the Google Colab. And we're displaying it using the HTML style. This is for headers and the rest. It displays a colorful header that I've already shown. So Using this text widgets, we can see the total movies, the watch movie, the search result, and average rating. And this all will be shown using the IPyWidgets.html. For search and control button, this is for search and control button. These create all the input tools that we can interact with, like search box, search button, show all button, sort drop down, sort button, recently watched button, and clear button. These all are the buttons, and each has a label, color, and the actions attached to it later. This is for output area. This is where our search result or movie list will be displayed dynamically. And this is for UI setup. It arranges search, sort, and other control buttons horizontally that we can see in the video. This is for global variable, and it keeps track of which movies are being displayed right now, or so sorting or refreshing works correctly by using the update stats function. So for update stats function, it updates all the smaller statistic cards like watch count and search result count. For display movie with widget function, it creates an HTML card for each movie, which got like title, rating, year, and genre in each movie. If the movie already watched, then it shows the status. If it not watched, then it shows a watch now button. And when we click it, it calls the watch movie function here and display a success message and calling the updated status in order to refresh our UI again. This is for display movie with widget, but this one is for the entire movie list. It will show a header with the count and title like all movies or search result, that kind of thing. And for search click button, for search click function, it triggers when search button is clicked. It reads the keyword from search box that we put in above the code, and it clears the output area and displays the searching, that kind of thing. And it will run the linear search after it got the keyword and update the search result and show with the current display. Now finally, it will call the display movie with widgets that I've explained above. So for show all click button function, it shows all movies again and result to movie copy. For on sort click, it triggers once sort button is clicked. It reads sort button down dot value that we can see in the markdown, and it will sort using the current display and our quick sort function based on our rating, year, or title that we choose in the markdown box, and it will update the display list. Or for on recently watched click function, it shows all movies that we've marked as like watch, which we can get from by clicking the button, and retrieve from recent stack. And for clear click, it clears all recently watched movie by calling the clearly recently watch function and update the status. Final thing for the event findings, it connects each button to its function using the search button, show all button, that kind of thing. And this is the final display with the output area. This is the end of the code explanation.
The backends is the engines of the system. We used a list of dictionary containing 40 movies with attributes such as title, rating, year, genres. The first one is linear search. Our search function scans through the datasets linearly. If the keywords match any title or genre, it is added to the results list. This is simple but effective for small datasets with big O time complexity. The second, quick sort. For sorting, we implemented the quick sort algorithm. It chooses a pivot, partition the datasets, and recursively sorts. We use quick sort for its big O and log an average complexity, much more efficient than bubble sort or instruction sort for larger lists. We managed recently watched movie with a stack structure. Each time a movie is watched, it is pushed onto the stack with a timestamp. When displayed, it is shown in reverse order. The latest movie appears first. This mimics real user behavior, last in first out behavior.
In our team, each member has a specific focus. One of us works on the UI and user experience, another handles the system architecture and flowchart. While my role was to implement the logical core, the part that makes the system surely think, search, sort, and respond to user actions. As I'm responsible for the back-end development and algorithm design in our movie recommendation system project. The backend is like the brain of our project. It processes the data, performs all the computations, and provides meaningful output to the interface. So I explain in detail how I build the logic using basic and powerful algorithms and data structures, namely linear search, quick sort, and stack, and how these are combined to create a fully interactive recommendation system. Now I will explain backend overview and design philosophy. Before diving into the algorithm, let me first give an overview of how our backend is structured. Our system is written entirely in Python, and we made a deliberate choice not to use artificial intelligence, APIs, or external libraries for recommendation. Instead, we focused on implementing classical algorithms to show that even without AI, we can create a smart, and interactive system. The main data structure we use is a list of dictionaries. Each dictionary represents a movie and it contains 4 key attributes. First one, the movie's title. The second one is if its IMDb rating, and it's released here at a list of genres. Altogether, our dataset contains 40 movies. This allows the backend to handle searching, sorting, and dynamic updates efficiently. Another design principle we follow was modularity. Every function of the backend performs a single, clear task, for example, searching, sorting, watching, or clear history. This modular design makes the system easy to understand, debug, and extend in the future. For instance, if we wanted to connect it to a real database or an AI model later on. Now let's talk about the first major part, the search algorithm. When a user types a keyword in the search bar and clicks the search button, the system needs to scan through all the movies and find any title of genre that match the keywords. I implemented this using linear search, one of the most fundamental searching algorithms. Here starts work step by step. The program first takes the input from the user and converts to lowercase, so the search begins case insensitive. Then it starts from the first movie in the dataset and checks if the keywords appear in the title or any part of the genres. If a match is found, the movie is added to a results list. The process continues until all movies are checked, and finally the system returns the list of all matching movies. The entire process runs in a big O and time complexity, which means it's checked every movie one by one. For our dataset of 40 movies, this is very efficient. The user experienced almost instant results. I also added a feedback system. If the users leave the search bar empty, the backend shows a warning message like please enter a keyword to search. And if no match is found, it displays a friendly message saying no movies were found. This ensures the backend always handle user input safely and avoid crashes. After searching, the next cohort is sorting. Users can choose to sort movie by rating, release year, or title, and each option can be sorted in both ascending and descending order. To implement this, I used the quick sort algorithm, which is one of the fastest and more efficient sorting algorithms in computer science. Quick sort works by using a divide and a conquer approach. First, it picks one element as a pivot. In our case, the first movie in the list. It then divides the remaining movies into two groups, those with value less than the pivot and those with value greater than the pivot. Depending on whether we are sorting ascending or descending, then it recursively applies the same process to each group until everything is sorted. The beauty of quick sort is that, on average, it runs in big O and log n time complexity much faster than simple sort like bubble sort or insertion sort. For example, when a user selects rating high to low, the algorithm arranges movies so that the highest rated movie comes first. Similarly, choosing year new to old sorts by release year, showing the newest things first. This sorting happens dynamically, meaning the system re-renders the movie list immediately after sorting, creating a smooth and interactive experience for the user. The third major backend feature I developed is the recently watched system, which uses stack data structure. In simple terms, a stack follows the rule last in, first out or LIFO. This means the most recent item added is the first one to be removed or displayed. Yet the sound is work in our project. When the users click the watch buttons on any movie, the system calls the watch movies function. This function pushes that movie along with the current timestamp onto the stack called recent stack. Then when the users click on recently watched, the system displays all movies in reversed order, showing the latest watched movie at the top. I also added logic to prevent duplicates. If the user tries to watch the same movie again, the system checks whether it is already in the stack using a helper function called isMovieWatched. If it's already there, instead of adding it again, the backend displays a notification this movie is already in your recently watched list. This stack design makes our system more interactive and user-friendly. It gives a sense of history and memory, just like real streaming platforms such as Netflix or Disney+. Now let's talk about how the backend connects to the front end. The UI was made using IPyWidgets, which allow interactive buttons, drop-downs, and text field inside Jupyter Notebook. Each widget has an event handler that is connected to a backend function. For example, when a user clicks the search button, it triggers the function of search click. The functions call my linear search algorithm and update the output area and display the search result in real time. Similarly, clicking on the start button calls on sort click, which runs the quick sort algorithm based on the drop-down selection. The recently watched and clear buttons are also linked to their respective backend stack functions. All these functions are wrapped inside a main layout that includes custom HTML and CSS style to make the outputs visually appealing. So, while the user interacts with the front end, all the logical operations and data manipulations happen in the backend layer that I developed. One of my important backend responsibility was to make the system robust, meaning that it should handle every possible user action gracefully. For example, if a user searches with an empty string, the system shows warning message rather than producing an error. If a movie is already in the recently watched list, instead of adding it twice, the backend shows a non-disrupted alert. If the user tries to clear the list when there is nothing to clear, it displays no movies to clear. All these checks and notifications make the system more reliable. They also ensure that even though our system doesn't use a database, it still behaves in a controlled and intelligent way. The backend also updates and displays real-time statistics at the top of the interface. This includes the total number of movies in the dataset, the number of movies watched, the number of current search results, and the average rating of all movies. Every time the user search and watch a movie, the backend recalculates this value and updates the displays using HTML widgets. This gives the user a sense of live interaction and also demonstrate how data and algorithms can be linked to dynamic UI components. I also focused on efficiency and scalability. Even though the dataset is small, I structured the backend so that it could easily be extended in the future. For example, the linear search function could later be replaced by a binary search if the dataset grows large. The quick sort function could be replaced with merge sort or heap sort if we want to optimize specific scenario. And the result stack could be connected to a real database so the recently watched data is saved permanently. I also wrote the function to be reusable and independent, which means other developers could use this same backend module in different projects without major changes. This reflects one of our main project goals to show the fundamental algorithmic knowledge can be applied in real-world systems and stay powerful, scalable, and maintainable. To summarize my part of the project, focused on building the logical foundation of our movie recommendation system, using linear search to find movies quickly and accurately, quick sort to organize them efficiently, and a stack structure to manage user history dynamically. These algorithms together form the core engine that powers the UI and enables user interaction. Through this project, I learned how fundamental algorithms can still create real functionality without depending on artificial intelligence. Now, I hand over to my teammates who will explain the UI UX development process and show how the user interacts with the system visually.
And for the front end, we focus on making the system interactive visually efficiently using IPyWidgets, HTML, and CSS. IPyWidgets were used for text boxes, drop-downs, buttons like search, sort, recently watch, and clear all. So HTML, I use HTML and CSS to style each movie as a card with the title, year, rating, and genres. We use the output widgets to refresh the display dynamically each time an action is performed. So if every user click a core specific event handler function and which then update the display with newly generated HTML. Okay, I will show an example. And as an example, clicking a search call on a search click, a perform search and it's gonna update the display. So if you click sort, a sort function, the sort reset, and it's gonna re-render sorted movie card. So and next we will click watch now, and what it do is update stack and display simultaneously. So this made this application feel like a mini web application running inside a Jupyter notebook. And for the overview, I will start by showing all the 14 movies, so you can see their display as a card by rating. Here, general tag, as I mentioned it before. So I will type sci-fi in the search bar and clicking a search. Okay, instantly, only science fiction film Inception and The Matrix will be shown. Next, I will select rating a high to low and click the sort. The quick sort algorithm rearrange the list in real time. Now I will click watch now on Inception. So a message will be pop up and saying it was added to the recently watched stack. If I click recently watched, the Inception movie that I just watched it's gonna appear at the top. And if I watch another movie like The Matrix, it goes up, it goes above it, and proving the stack really well. Finally, clicking clear or it gonna empty all the stack and counter reset.
Last but not least, the architecture and algorithm work smoothly, giving instant feedback to user actions. Quick sort gives efficient sorting, linear search if first for small datasets, and stack operations are simple and effective. The UI responds dynamically without reloading the page. And we also faced small challenges such as no database storage, watch list result each session, and limit dataset we have only 40 manual entries. Another thing is scaling to 1,000 of moving would needs optimization, but we have future improvements like integrating TMDB API for live movie data, add user profiles and save watch history, implement machine learning for advanced recommendations. Finally, our project shows how Python can be used beyond computations. To build real interactive applications, we combined system design, data structures, and UI to create a functional recommendation system. This project strengthened our teamwork and our technical skills in both back-end and front-end development. Thank you for listening to our presentation.